When an object moving along a circle or along a curve, and it will experience a acceleration, and that acceleration is due to some kind of force. But now in this video, we just derive mathematically the relation between the velocity along the line, along the tangent line, to the acceleration, which is towards the center. To begin with, so you will see we'll have, let's see, have a delta t time has passed. It goes through this arc length. Therefore, then, but the direction change. So at one point, it's in this direction, v1. And after delta t time is v2. But now if you work out the vector, enlarge the view, from A1, v1 change to v2. So this addition of delta v and this v1 plus v2, you get these new vectors. And then that is your velocity change at delta t time. It's a vector. So if you recall the definition of acceleration as a vector is a delta v and divided by the delta t, which is a scalar. So that delta v is a change in velocity. In this case, is along that direction. Now that's a finite. But then if you work out details, now what is the magnitude of this direction, of this velocity change? And if you work through the math, change in the angle and the change in the velocity. So if you look at the math down here, it is changing this much and then changing this much. So therefore, v times delta theta, if you recall your math, it will be is magnitude of the velocity change. Now, and then the angle change, of course, is equal to omega times delta t. That's the angular velocity times delta t, and then you have a v divided by r times delta t. And then once we have this relation, substitute to this angle change, and then we will have delta t and times v squared and divided by r, and relates to the v. The v, where this math is toward delta v, and which is the magnitude of velocity change, which is basically sideways to the velocity itself. And finally, the acceleration, you divide by delta t again, so the delta t is gone, so the acceleration is, the magnitude of acceleration is v squared divided by r. So v squared, if you look at this, so to summarize the result from this, and the magnitude of the acceleration vector is a equals velocity squared, that's tangential divided by r, and that's all due to these arguments, mathematics. That's usually called kinematics. And if you think about this, where is the direction? A direction, if you think about this closes, the delta c approaching 0, and then the actual direction is towards the center. So these actually summarizes the relation. If you just want to solve some simple problems with involving acceleration, and without asking where you get this answer, and these are going through the answer, and these are the result. In other words, if an object moving with velocity v along this direction, its acceleration is towards the center. So there must be some force that bring it to make it turn. So that's acceleration. The value relates to the tangential direction velocity and divide by the radius. And the center is, of course, towards the center. Okay, when you apply this centripetal acceleration, actually the acceleration towards the center, you still using Newton's second law, and then force. Now the force is actually to the center divided mass, and that's acceleration to the center. Or if you just want a numerical answer and you want to, and F equal ma mass times v squared divided by r.